Hello students, in this video I am going to explain the concept of Fermat-Little theorem. This is very important theorem of number theory. According to this theorem, if A is positive integer and P is prime number such that GCD of A comma P is 1, then A raised to P is congruent to A mod P. This means that A raised to P minus A is divisible by P. In more general, we can say that if A is some positive integer and P is prime, given that GCD of A comma P is 1, then A raised to P minus 1 is divisible by P. That is, A raised to P minus 1 is congruent to 1 mod P. Now, I am going to prove this Fermat theorem. Now, x1 plus x2 whole raised to P can be written as PC0, x1 raised to P, PC1, x1 raised to P minus 1 into x2, PC2, x1 raised to P minus 2, x2 square till PC, P, x2 whole raised to P. This is simply by using binomial theorem. x1 plus x2 whole raised to P, PC0, x1 raised to P, PC1, x1 raised to P minus 1, x2. Power of x1 start reducing and power of x2 is increasing, where P is prime number. So what can we say? We can say that PC0 x1 raised to P. This is simply x1 raised to P and this is simply x2 raised to P. So we can therefore say that x1 plus x2 whole raised to P is nothing but PC0 can be replaced as 1 x1 raised to P and this PCP is simply 1. This is x2 raised to P. And what about this PC1? x1 raised to P minus 1 into x2, PC2, x1 raised to P minus 2 x2 square. Now, what about P? P is prime number. If P is prime number, P is prime number. Very interesting idea. PC1, PC2 all are divisible by P. So can we say this all terms are divisible by P? Divisible by P. So simply we can say that x1 plus x2 whole raised to P is congruent to x1 raised to P plus x2 raised to P mod P. In more general, what can we say? X1 plus x2 plus x3 till x1 xi whole raised to P is congruent to x1 raised to P plus x2 raised to P plus xa raised to P mod P. Now putting x1, x2, x3 all equal to A. 1. Putting x1, x2 all equals 1. What can we say? This 1 plus 1 plus 1, how many times 1? A times 1. So A raised to P is congruent to A modulo P. And this, if this is A raised to P is congruent to A modulo P and dividing by A, so what we get? A raised to P minus 1 is congruent to 1 mod P. So this is what? Derivation of FLT. Now students, I am going to apply this Fermat-Little theorem. Now, find remainder when 6 raised to 33 is divided by 110. Now we are going to use FLT to solve this question. Now we are going to apply FLT to solve this problem. What is the remainder when 6 raised to 33 is divided by 110? This is very interesting problem. Now we are going to use FLT to solve this problem. Now, 33 is not a prime number. So 6 raised to 33 is same as 216 raised to 11. By doing this, what can we say? We can say that 11 is a prime number. So we can apply Fermet-Little theorem here. Now, 216 raised to 11 minus 216 is divisible by 11 because 11 is a prime number and a raised to p minus a is divisible by p. So, what about unit digit of 216 raised to 11? It is same as 6 raised to 11, which is equal to 6. So, unit digit of 216 raised to 11 minus 216 is equal to 0. Therefore, what can we say? 216 raised to 11 minus 216 is also divisible by 110. So, what can we say? 216 raised to 11 minus 216 whole divided by 110 is equal to m. M is some positive integer. Therefore, 216 raised to 11 is nothing but this is equal to 216 plus 1110m. So 216 raised to 11 is same as 6 raised to 33 and this is equal to 216 plus 1110m. Now what about when this whole number is divided by 110? This is equal to 106 plus 110 plus m plus 1. This is an integer. So what about remainder? Remainder is 106. Now again, this is a very interesting question. What is the remainder when 7 raised to 2019 is divided by 30? Now, we are going to apply FLT also here to solve this problem. Now, what about 7 raised to 2019? 7 raised to 2019. Now, 7 raised to 2019, we are going to divide by 13. 7 raised to 2019 is written as 7 raised to 12 into 168 plus 3 and this is again equal to 7 raised to 12 whole raised to 168 into 70. Now 7 raised to 12 is nothing but 7 raised to 13 minus 1. If you divide this by 13, remainder is 1. So this is 1 raised to 168 and this is 343. 343 is nothing but 5 is congruous to 5 mod 13. So what it means, if you divide 7 raised to 2019 by 13, remainder is 5. Thank you and see you in next video.